In this lesson, you will learn how to set up a site-to-site IPsec VPN. In today's IT infrastructure, VPNs are frequently used to join private corporate networks across the internet. IPsec is an RFC standard. So, whether your network contains only FortiGate devices or a combination of FortiGate devices and devices from other vendors, the principles of applying IPsec are essentially the same. In this lesson, we will examine the following topics: VPN topologies, site-to-site VPN manual configuration, best practices and troubleshooting. After completing this lesson, you will be able to select an appropriate VPN topology. By demonstrating competence in VPN topologies, you will be able to choose appropriate VPN topology for your network environment. First, you'll review the fundamentals of IPsec. IPsec is a suite of protocols that is used for authenticating and encrypting traffic between two peers. The three most used protocols in the suite are the following: Internet Key Exchange, IKE, which does the handshake, tunnel maintenance, and disconnection. Encapsulation Security Payload, ESP, which ensures data integrity and encryption. Authentication Header, which offers only data integrity, not encryption. FortiGate uses only ESP to transport the packet payload. is not used by FortiGate. Now, you'll review the fundamentals of IKE. IKE uses port UDP 500, and if NAT is enabled in a NAT scenario, UDP port 4500. IKE establishes an IPsec VPN tunnel. FortiGate uses the tunnel to negotiate with the peer and determine the security association, SA. The SA defines the authentication, keys, and settings that will be used to encrypt and decrypt that peer's packets. It is based on the Internet Security Association and Key Management Protocol, ISA-KMP. IKE defines two phases. Each IPsec SA negotiated during Phase 2 is direction-specific. So, in two-way traffic, there are two SAs per Phase 2. For Phase 1, there are two possible negotiation modes that can be used: main mode and aggressive mode. Phase 2 uses only one negotiation mode: quick mode. Site-to-site VPN is also known as point-to-point VPN. Site-to-site VPNs are the simplest type of VPN. In site-to-site, two peers communicate directly. Site-to-site VPN allows transparent communication between two networks that are located at different offices. One point-to-multipoint topology variation is called hub and spoke. The name hub and spoke describes how all clients connect through a central hub, similar to how spokes connect to hubs on wheels. In this example, the clients, spokes, are branch office FortiGate devices. For any branch office to reach another branch office, its traffic must pass through the hub. One advantage of this topology is that the VPN configuration and firewall policies are easily managed. System requirements are also minimal for the branch office FortiGate devices, because each needs to maintain only one tunnel, two SAs. In this example, 4 tunnels, 8 SAs, are required in the hub. One disadvantage is that communications between branch offices through HQ will be slower than with a direct connection. This is especially true if your HQ is physically distant, like it can be for some global companies. For example, if your HQ is in Brazil and you have offices in Japan and Germany, latency can be significant. Also, if the FortiGate at HQ fails, VPN failure will be company-wide. In the example shown on this slide, the FortiGate at HQ must be much more powerful because it handles 4 tunnels simultaneously, 8 SAs. So, what would a topology look like if some or all branch offices could bypass HQ and connect directly to each other? This slide shows VPNs in a mesh topology. Two variations of mesh topology exist. Full mesh connects every location to every other location. Like the previous hub and spoke example, the example shown on this slide contains 5 locations. To fully interconnect, every FortiGate device requires 4 VPN tunnels, 8 SAs, to connect to the other FortiGate devices. So, in total, 20 tunnels are required. That is 3 more tunnels per FortiGate than was required in the hub and spoke example. If this example was expanded to 6 locations, 30 VPNs would be required. If it was expanded to 7 locations, 42 would be required, and so on. This topology causes less latency and requires much less HQ bandwidth than hub and spoke. Its disadvantage? Every spoke FortiGate must be more powerful. Partial mesh attempts to compromise, minimizing required resources but also latency. Partial mesh can be appropriate if communication is not required between every location. However, the configuration of each FortiGate is more complex than in hub and spoke. Routing, especially, may require extensive planning. Generally, with the more locations you have, hub and spoke will be cheaper, but slower than a mesh topology. Mesh will place less strain on the central location and be more fault tolerant, but it will also be more expensive. To review, this slide shows a high-level comparison of VPN topologies. You should choose the topology that is most appropriate to your situation. Each VPN topology has its advantages and disadvantages. Auto Discovery VPN, ADVPN, is a FortiGate feature that achieves the benefits of a full mesh topology with the easier configuration and scalability benefits of hub and spoke and partial mesh topologies. First, you add the VPN configurations for building either a hub and spoke or a partial mesh topology to the FortiGate devices. Then, you enable ADVPN on the VPNs. ADVPN dynamically negotiates tunnels between spokes without having them pre-configured to get the benefits of a full mesh topology. ADVPN requires a dynamic routing protocol running over the IPsec tunnels so that spokes can learn the routes to other spokes after the dynamic VPNs negotiate. This slide shows an example of how ADVPN works. An administrator configures IPsec VPNs on multiple FortiGate devices to form a VPN partial mesh topology. There are 2 hubs. Hub 1 has 3 spokes. Hub 2 has 2 spokes. The administrator also enables ADVPN in all the VPNs. To do that, the administrator must enable the following IPsec Phase 1 settings. Auto-discovery-receiver in the spokes VPNs. Auto-discovery-sender in the hub's VPNs that go to each spoke. Auto-discovery-forwarded in the hub's VPNs that go to every other hub. The dynamic tunnels between spokes are created on demand. Say that a user in Boston sends traffic to London. The direct tunnel between Boston and London has not been negotiated yet. So, the first packets from Boston to London are routed through Hub 1 and Hub 2. When Hub 1 receives those packets, it notices that ADVPN is enabled in all the VPNs through to London. So, Hub 1 sends an IKE message to Boston, informing Boston that it can try to negotiate a direct connection to London. On receipt of this IKE message, Boston creates a FortiOS-specific IKE information message, which contains its public IP address, its local subnet, the desired destination subnet, London subnet, and an auto-generated PSK to use for securing the direct tunnel. Alternatively, digital certificate authentication can be used instead. This IKE message is sent to London through Hub 1 and Hub 2. When London receives the IKE message from Boston, it stores the PSK and replies with another IKE information message that contains London's public IP address. After the reply arrives at Boston, the dynamic tunnel is negotiated between both peers. The negotiation will succeed because London is expecting a connection attempt from Boston's public IP address. Good job! You now understand VPN topologies. Next, you'll learn the steps for configuring site-to-site VPN. After completing this section, you will be able to deploy a site-to-site VPN between two FortiGate devices. Compare route-based configuration mode to policy-based configuration mode. Configure redundant VPNs between two FortiGate devices. Understand hardware offloading requirements. By demonstrating competence in VPN configuration, you will have better understanding of deploying a VPN between sites. Because encapsulation styles and other settings vary, and any mismatches cause VPNs to fail, FortiGate includes VPN templates to overcome this problem. You can use these templates to simplify VPN setup, reducing the guesswork about what settings are compatible between devices. The VPN wizard uses 3 templates to make IPsec VPN creation easier for administrators. The VPN wizard comprises a 3-step process. Administrators provide the VPN name, remote IP, authentication method, interfaces, and subnets. After you have completed the VPN wizard, it automatically creates many of the required objects: addresses and address groups, static routes, policies, Phase 1 and Phase 2 settings. On FortiGate, there are 2 ways to manually configure an IPsec VPN. These configurations define how to create the firewall policies for VPN traffic: route-based configuration and policy-based configuration. How do you know when to use policy-based or route-based? Generally, try to use route-based because it offers more flexibility and control. Transparent mode supports only policy-based VPNs. How are the 2 configuration modes different? In a route-based configuration, FortiGate automatically adds a virtual interface with the VPN name. 2 firewall policies with the action set to accept are usually required. One for sessions originating on the local network and another for sessions originating on the remote network. You also need to route the VPN traffic to the virtual network interface. Usually, you'll use static routes. This is the type of VPN configuration created by the VPN wizard. In a policy-based configuration, only one firewall policy with the action IPsec is usually required. The policy is bidirectional. By default, the GUI hides the policy-based configuration settings. Both sides of your VPN don't need to be configured to use the same mode. You can configure one peer as route-based and the other as policy-based, but the Phase 1 and Phase 2 settings must match. If FortiGate is operating in transparent mode, then only policy-based VPN will be used. To achieve full redundancy between VPNs, route-based VPN is used. If you are configuring a custom VPN, you can start by using the wizard. Click Custom, no template. Configure the WAN IP address for the remote FortiGate device and indicate which network interface on this local FortiGate is the gateway that leads to it. FortiGate will use this to connect to the other end. If your peers use pre-shared keys for the initial IKE authentication, both peers must be configured with the same pre-shared key. For Phase 1, choose which encryption and authentication to propose, and so on. They must match too. If peers can't agree on IKE security, even Phase 1 won't be established. If you need detailed control of your VPN, such as for IKE version 2, you can still configure it manually. After Phase 1 is complete, Phase 2 begins. This sets up the ESP tunnels that will be used for actual data transfer. For each subnet on each end of the VPN, you can specify different levels of ESP security. For example, connections to the finance LAN might need larger key sizes and stronger authentication. To do this, configure multiple Phase 2 entries. For simplicity, in the example shown on this slide, we show only one Phase 2. The local address is the LAN, and the remote address is the remote LAN. Remember that if traffic doesn't match the quick mode selectors of any Phase 2 SA, the IPsec engine will drop the packet. Usually, it's more intuitive to filter traffic with firewall policies. So, if you don't want to use quick mode selector filtering, you can just create one Phase 2 with the quick mode selectors set to 0.0.0.0/0. If you use the wizard, it creates routes and policies suitable for a route-based VPN. However, what if you have, for example, a FortiGate in transparent mode? Transparent mode supports only policy-based VPNs, which cannot be created with the wizard. The wizard creates only route-based VPNs. Remember, first, you must enable the GUI to show policy-based IPsec options. Configure your phases as before, then create a policy. When policy-based VPN settings are visible, an additional firewall policy with the action setting is available. Choose IPsec. Then choose the policy-based VPN to use. With a route-based VPN, firewall policies are different. Usually, there are two policies, not one. The interface doesn't match a WAN interface. It matches the virtual interface, which, in this example, is named to remote. The VPN wizard is the easiest way to make these policies. If you use the wizard, you can skip this step. But if you want to manually set up a VPN, use the settings shown on this slide as examples. In route-based VPNs, you also need to route VPN traffic destined for the remote LAN to the IPsec interface. If you use the wizard, this was created for you automatically. To do this manually, usually you'll add a static route. You usually do not need to do this step when configuring a policy-based VPN, because traffic that does not belong to any internal subnet is routed through the default gateway, which uses the WAN interface. On the GUI, there is a tool that you can use to monitor the status of your IPsec VPNs. Using this tool, you can see how much traffic has passed through each tunnel. You can also start and stop individual tunnels and get additional details. If the tunnel is up, a green arrow is displayed next to its name. If it is down or not in use, then a red arrow is displayed. The hub-and-spoke topology is inherently not fault-tolerant. If something fails, then all VPN tunnels might close. How can you make your hub-and-spoke or point-to-point VPN more resilient? Provide a second ISP connection to your site and configure two route-based VPNs. If the primary VPN fails, another tunnel can be used instead. There are two types of redundant VPNs. Partially redundant. On one peer, usually the hub, where a backup ISP is available if the main ISP is down, each VPN terminates on different physical ports. That way, FortiGate can use an alternative VPN. On the other peer, each VPN terminates on the same physical port, so the spoke is not fault-tolerant. Fully redundant. Both peers terminate their VPNs on different physical ports, so they are both fault-tolerant. SD-WAN feature can also be used for VPN redundancy. So, how do you configure a partially or fully redundant VPN? First, create one route-based Phase 1 for each path. One Phase 1 for the primary VPN and one for the backup VPN. Enable dead peer detection, DPD, on both ends. DPD is a method that IPsec gateways use to detect when the VPN tunnel to its peer is down. Second, create at least one Phase 2 definition for each Phase 1. Third, because these are route-based VPNs, you must add at least one static route for each VPN. Routes for the primary VPN must have a smaller distance or smaller priority than the backup. This causes FortiGate to use the primary VPN while it's available. If the primary VPN fails, then FortiGate automatically uses the backup route. Alternatively, you could use a dynamic routing protocol, such as OSPF or BGP. Finally, configure firewall policies to allow traffic through both the primary and the backup VPNs. On some FortiGate models, you can offload the encryption and decryption of IPsec traffic to hardware. The supported algorithms depend on the model and type of processor on the unit that is offloading the encryption and decryption. By default, hardware offloading is enabled for the supported algorithms. This slide shows the commands you can use to disable hardware offloading per tunnel if necessary. Good job! You now understand site-to-site VPN configuration. Next, you'll learn best practices and troubleshooting for site-to-site IPsec VPNs. After completing this section, you should be able to use best practices to deploy site-to-site IPsec VPNs. Verify the offload of IPsec VPN. Troubleshoot common site-to-site IPsec VPN problems. By demonstrating competence in knowing best practices and troubleshooting techniques, you will be able to apply best practices for IPsec VPN deployment and use basic troubleshooting techniques when working with IPsec VPNs. Most IPsec VPN issues occur when you are creating tunnels between FortiGate and a third-party device. Unlike FortiGate, some vendors don't support quick mode selectors that are 0.0.0.0/0, or that use subnets of different sizes. So, those vendor devices require a different SA and a different Phase 2 for each pair of local and remote protected subnets. In these cases, FortiGate configuration might be complicated and time-consuming, because administrators need to create several different Phase 2s. One alternative is to use the command set mesh-selector-type subnet when configuring Phase 1. When you use this command, FortiGate automatically creates Phase 2 on demand. This can simplify FortiGate configuration considerably. To verify if IPsec traffic is offloaded, use the following CLI command: diagnose VPN tunnel list. This command shows the status and statistics for each VPN tunnel. If the output contains a line that contains NPU_flag, the tunnel is being offloaded for hardware acceleration. Remember, you must get initial packets from both directions before checking the NPU_flag field. Otherwise, it is expected to be 0/0 initially. What do you do if, after creating a tunnel, it does not come up? When troubleshooting a tunnel that does not negotiate, look for setting mismatches first. Most connection failures are caused by misconfiguration. If you do not see any configuration mismatches, run the IKE real-time debug. The output of this command is extensive. It shows the Phase 1 and Phase 2 negotiations step by step. If the negotiation fails, the IKE real-time debug shows messages that can guide you toward a resolution to the problem. To enable and use IKE real-time debug, 1. Create a filter using the following command: diagnose VPN IKE log-filter DST-ADDR4 IPsec's peer public's IP address. Enable the debug using the following commands: diagnose debug application IKE-1 diagnose debug enable. 3. Try to open the tunnel while the debug is running and capture all the output. 4. After you have captured the output, stop the debug using the following commands: diagnose debug reset, diagnose debug disable. Keeping a real-time debug running on the background of a FortiGate for a long time is not recommended. This slide shows some output for a successful Phase 1 negotiation using main mode. The first line shows the arrival of an IPsec packet from the IP address 172.20.187.114. The third line indicates that the peer is using main mode. A bit later, the debug shows that FortiGate accepted the SA proposal from the remote peer. It displays the name of the Phase 1 that matches the proposal. In this case, it's the name remote. FortiGate replies to the first main mode packet. Then, the second main mode packet arrives. FortiGate replies again, and the third main mode packet is received. After finishing the negotiation, the output displays messages that indicate that the key exchange was successful and the IKE SA was established. This slide shows some output from a Phase 2 negotiation. The full output is much longer than this. The slide only shows a sample of some parts of that output. The first line announces the arrival of the first quick mode packet. The second line shows the quick mode selector proposed by the remote peer. In this case, it's 0.0.0.0/0 for both the source and destination. Several lines below, the debug displays the quick mode selector that was successfully negotiated between both peers. Finally, the last two lines show that the tunnel is up and the IPsec SAs are established. If there were any problem in the negotiation of either the Phase 1 or Phase 2, the output would show an error message. This slide shows a summary of the most common problems and solutions. If the tunnel is not coming up, use the IKE real-time debug. You will usually see one of the error messages listed in this slide in the output. If the tunnel is bouncing, you will usually see the message DPD packets lost in the output. This indicates that the problem might be on the ISP side. If the tunnel is up, but traffic does not go through, use the debug flow. It could indicate that packets are being dropped at either the local or remote gateway. Packets are not being routed properly. Packets do not match the quick mode selectors, so they are being dropped. Congratulations, you have completed this lesson. Now, you will review the objectives that you covered in this lesson. This lesson covered the following objectives: reviewed IPsec and IKE, choose an appropriate VPN topology, compare route-based configuration mode to policy-based configuration mode, deploy a site-to-site VPN configuration between two FortiGate devices, understand hardware offloading requirements, configure redundant VPNs between two FortiGate devices, use best practices to deploy site-to-site IPsec VPNs, verify the offload of IPsec VPN. Troubleshoot common site-to-site IPsec VPN problems.